Okay, so here's part 2 for our partial fractions, decomposing irrational into partial fractions. This is type 2, and this is when we have repeated factors, okay? And the game changes just a little bit when we have repeated factors, okay? And I'm not going to explain so much why this is, I'm just going to give you the pattern. So if we have x plus 3 times x plus 3, it's not like this. If they're different, we can express it like this. But if they're the same, what we have to do is anything that repeats itself, we have to split it up even further, I guess you could even say. So we have to kind of tear this down into partial fractions. So this is the pattern when the factors in the denominator repeat. So you do kind of the first factor, x plus 3, and then you'd find another partial fraction that covers the x plus 3 squared. So I won't do an example where we actually expand something to see that, but I'll just kind of give you this is the setup. This is the pattern. So solving for a and b, very, very similar to type 1, right, when we had different fractions. So let's just see how this changes just a little bit, though. So we're going to multiply both sides by x plus 3 squared, obviously. We're going to have x plus 5 equals a times x plus 3 plus b times what? Nothing, just b. Okay? So you get here, and again, you have two options to go from here. Well, you probably have some more, but two main options that we've studied. You could equate coefficients, or you could let x equal something. Just pick something out of the hat. So if we let x equal -3, just for this, and I don't know if anyone's noticed this yet at all, but when we do substitution, we are choosing values that technically are restricted values. So I don't know if that causes put anyone in a fluff or not, but anyways, that's maybe the subject of another lesson. I don't really want to explain why we can do that, but because we are sort of changing how this looks, and we're just kind of comparing this value internally, it's not like we're actually using this x to get an answer for this. We're just sort of using this as a hypothetical almost, okay, to find the constants. So if we do this, then what we can do is we can say -3 plus 5 equals a times 0 plus b, and we get b pretty quick here. Looks like b is 2. And if we have b equals 2, we can basically, okay, so let's let b equal 2 because we know that already. And because we're just talking about a straight kind of polynomial, it's just an equation, we could basically let x equal anything else and we could solve for b, right? So you could let x equal anything else. So let's let it equal 0. I don't know, just 0. So then we've got 5 on the left side, 0 plus 5. And we've got a times 3, or that's just 3a. And then we've got b we know is, yeah, 3a. And then b we know is 2, so this is plus 2. So a is 1. Okay. So the big thing with type 2, and again, this is just a bit of a shorter lesson really, because we did the heavy lifting in the previous lesson. But if you have repeated factors, you have to write them out like this. So let's take a look at another example, and here is how you would do this one. Okay. So if we have 1 over x minus 1 all squared times x plus 1, it looks like we have 3 factors. So we're going to have 3 terms. But this one has got to be split up like this. Okay? So again, that's the only slight difference from kind of type 1. All right. So with 3 constants, it does get a little bit longer and trickier, but why don't you guys take a stab at this and see if you can solve for the coefficients of a, b, and c. So give that a try here. Okay, so once again, if we're looking at this here, you want to multiply by this right here, okay, to every term, and that's going to give you this right here, this row right here. So how many of you did substitution? Did you do substitution here? You did this one? Okay, substituting values? Sure. So this is what you do when you pick values to substitute, right? You try and get rid of at least one term. So, you know, if we have these factors here, x equaling 1 or negative 1 would be good substitutions because that gets rid of a term. And of course, x equals 1, gets rid of this whole term and this whole term. So that's what I did first. And you're left with just the b, and that equals 1/2. So when you substitute again, you can let x equal any value you want, but you can also now let b equal 1/2. So that kind of whittles down your unknowns as well. Then you can isolate for a second variable. So knowing b and c, again, you can let x equal any value you want and solve for a. And so I just chose a random value of x equals 0. Got a equals negative 1/4. So everyone that I saw so far, I think, got these values. If you chose the equating the coefficients, okay, you can still do that with this one here. Now watch how this works. If we only have a 1 on the left side, okay, then the x squared term on the left side has a coefficient of 0. Okay, so this gets a little bit tricky, but it is, I think it's still pretty neat. It's still pretty cool. Look at the x squared terms. Okay, I'll just highlight them here. So here's an x squared term, and over here is an x squared term. So if you gather those and factor the x squared out, you get a plus 1/4. Okay. And over here on this side, there's a 0 coefficient for an x squared term because there's no x squared term that shows up. And so that means you let a plus 1/4 equals 0. That's another way to get your a value. Over here as well, you could do the same thing. Like you could also find a, because here's a constant a, and here's the other constant. And so the constant over here is 1. So if you let these, this constant right here equal 1, then you can also find your a of negative 1/4. Okay. I guess that's, once you find your b and c, this is the way you can find a. Anyways. So this is what your answer should look like. How many of you got that answer? Okay. As I mentioned before to one of you there, try not to leave fractions in the numerator. Split them up like this. So if it's negative 1/4, put the 1 here and the 4 down at the bottom. And you don't have to use different colored pens either in your answer. Just saying. Okay? Any questions on that? All right. So I do have some other questions for you to do as well on that piece of paper. So where are they? So you can do number 2 as well. And of course these have repeated binomial factors. Who knows what's. So now with those 2 lessons, you can do questions 1 and 2. So that's what you can work on now. Any questions?
If it was cubed, how would you do it?
Okay, if it was cubed, that's a good idea. So if it was cubed, then you'd have to go x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed. And then times, or plus the other factors. So yeah, you just keep going for as many factors as you have. Okay? So take the last little bit of class and work on that assignment, and yeah, then we'll go over some more questions tomorrow.